Good morning, everyone. Good morning, everyone. We are in the third webinar of Emeralds. We are admitting people and we are starting in a minute, just a few minutes to start the actual webinar. So while people are entering the room, and then we start. So I think you can see my screen. Please confirm if you see my screen. Okay, I think you can. So there is a raised hand already. Let me see. So some practical let's say details about this webinar. We are recording the webinar today. You can see here the agenda of today. It's 1 hour webinar. So this is the agenda. There will be a welcome and general review of the project from Konstantinos Flukas, which is the project coordinator of the project. And then there will be the contribution from TU Delft, Gruppa 93, Gruppa 93 again, and the more technical one, and at the end, Q&A session. Obviously, Konstantinos will introduce the other speakers after him. So welcome everybody. Just a few things that I want to say that please during the webinar keep your questions if you have for the speakers in the Q&A session, which is at the bottom of your screen. And please put there and a note in the chat, because the chat is for general purpose matters. The webinar is recorded, will be shared on the Emeralds website and on the YouTube channel, and all the slides will be shared after the webinar and will be available for download on the website. So I pass the floor to the coordinator of the Emerald project. Good morning, Konstantinos.
Yeah, hello, good morning, everyone. Thank you very much for joining this webinar. And thanks, Marielle Ditz and Trust IT, who organized this webinar. It's a good opportunity, to bring people from the domain together and discuss the progress and the developments of Emeralds. Of course, we're very open to questions regarding to the project milestones, and we can discuss it in the end of this webinar. Let me share my screen. I'm Daflukas Kostas. I'm a project manager and the engineer in Inlecom Innovation, who is coordinating Emeralds project. So a few words about the project. Emerald started in January 1st of 2023, and the project is about to end in the end of 2025. It's a research innovation action project with 36 months durations. And as you can see, we have a diverse background with 19 partners from 10 countries. It's the good thing is that we have together people from authorities that are stakeholders from cities like Hague and Rotterdam. Here in the consortium, we have a diverse background there, experts from several domains, from transportation, engineering, research. So about the Emerald's vision. So what we are doing here in Emerald's. Emerald's vision is to design, develop, and create an urban data-oriented mobility analytic as a service consisting of, of the so-called Emerald services, combined in a proof of concept prototype capable of exploring the potential of extreme urban mobility data. This toolset, suppose that will enable the stakeholders of the urban mobility ecosystem to collect and manage ubiquitous spatio-temporal data of high volume, high velocity, of a high variety. The toolset will offer advanced capabilities in, for example, data mining, that includes the searching and processing of large amounts and varieties of urban mobility data, and its efficiency will be assessed and validated in 3 pilot use cases. We have together the one use case leader, Juris and Christine from Riga, and group 93. We are now in the phase that we're getting into the last year of the project. So we have some midterm results, and the final results are about to start within the end of the next year. So thank you very much. Now we'll pass the floor to Winnie, who is a technical expert and a researcher in TAVU Delft. So Winnie.
Thank
Yes.
you, Kostas, for your introduction. You're still sharing your screen? I can share mine.
Yeah, thank you very much.
Good. Yes, so as Kostas already said, my name is Winnie Damen. I'm an associate professor at the Delft University of Technology. And what I will do today is the introduction of the use cases, which is a part of work package 5, which is led by Sasha Hogendorn-Lancer. In this project, we will develop emeralds, so-called emeralds, which all have their own functionality. So they all aim at processing big data, adding functionality, and be able to provide insights into certain processes within transport and mobility. Now, whereas the technical partners are developing these emeralds, the next step is to test these emeralds in a real-world situation using real data sets, and also taking into account stakeholders that are involved in the processes that are subject of the emeralds. So what we want to do in the use cases is to investigate and to assess the applicability and also the potential of the developed emeralds. So that means that how much can we improve the functionality using these emeralds rather than the current processes. We do this testing on a large variety of aspects, including the data acquisition, and it comes really into data acquisition on extreme scale. So we're talking about big data sets, but also the processing of it, the management of the data, and more importantly, also the analytics and the visualization. For this testing, we have developed 3 use cases, all in the realm of urban mobility. They all have a wide range of characteristics in order to demonstrate also the wide variety in the emeralds that are developed. Each use case divides or develops different pipelines in which different combinations of emeralds are made, which makes sure that we can include all the requests of the stakeholders. So that means that all the use cases differ in terms of data types, data sizes, availability of the data, and also type of application. If we talk type of application, I mean the estimation of a certain traffic state, the prediction of a certain traffic state, but also analysis that are needed for policy. I'll start with a very short introduction of the 3 use cases that we have. So the first one is aimed to assess, predict, and forecast risk and also crowds in crowded events. And in particular, we look here at the beach of The Hague, which is the so-called Scheveningen beach in the Netherlands. The aim here is to forecast different elements, so not only the counts of crowds, so how crowded it will be, but also the occupancy of the parking garages and the risks related to having too many people in a certain spot. And all this is input for crowd management. So how can the crowd managers arrange the situation such that there is no risk for the crowd itself, no crowd of crushing, no crowd, and that everybody is still comfortable at the beach. Our second use case is related to multimodal traffic estimation and production to be used for integrated traffic management. So in this case, we predict speeds and flows, both in the urban network and on the freeway, but also we take one step further to identify queue length and bottleneck. So where use case 1 focuses mostly on pedestrians, including the traffic leading pedestrians towards this beach area, use case 2 focuses on 3 modes, that is cars, public transport, and bicycles. This multimodal traffic management will be performed in Rotterdam, so we'll have close cooperations with the municipality of Rotterdam. And the last use case, which is also the topic of this webinar, focuses on public transport optimization in order to foster sustainable mobility. Here, the aim is not necessarily on the operations of traffic, but more for planning purposes. So what is done is in this use case is to derive trip characteristics from check-in data, where we specify exit stops and also trip chaining, but also we go further to analyze patterns of origin destinations, travel times, and delays. This use case will take place in Riga in Latvia. And again, in the webinar later, more information will be given on this use case. Now, in order to assess these emeralds within the 3 different use cases, there's a number of assessment categories. So when developing the emeralds, the technical partners already assess the software performance of the individual emeralds. Within the use cases, we try to assess the use case specific software performance KPIs. That means that what happens if a number of emeralds are combined and we look at the results of this combination of emeralds. How good is that result and how good do we want it to be for practice? Well, if we make the link towards practice, we mostly look into the use case business KPIs. So that really means that how well do the emeralds serve the current businesses of the stakeholders involved. Now, one side step is here that we will not be able to include the emeralds in the actual operations. So if we look at the value for the businesses, we mostly do that through interviews with the stakeholders. So how do they expect that these emeralds will have an added value for their businesses? So that is very shortly an overview of the use cases that we have and what is the role of the use cases within the Emeralds project. And that was my contribution for today. Thank you.
Thank you very much, Winnie. Thank you. So now we pass the floor to Christine Eglid from Group 193, please. So you sharing your screen? Right.
Yes.
Everything is perfect. Thank you. The floor is yours.
Okay, perfect. So, hello, my name is Christine. I'm from Group 19.3. Within the Emeralds project, I am directly involved with the use case 3. However, today I'm stepping into another role to represent the end user, where the goal of this presentation is to demonstrate how the activities and expected results of this project can be helpful and applied in a real-life context of Riga. But before dwelling into the specifics, I believe it's important to set the stage by providing some context about Riga, highlighting challenges related to public transport, congestion, and other relevant aspects. Yeah. As of the beginning of this year, Riga's population slightly exceeded 605,000 inhabitants. However, in recent years, it is possible to observe a decline in population, with one contributing factor being the movement of residents to neighboring municipalities. Despite this population shift, workplaces, educational institutions, and other key points of interest remain concentrated in Riga. Also, it is important to note that over 53% of Latvia's population, or more than 1 million people, live in Riga's metropolitan area. And just a quick side note here, Latvia's total population is approximately 1.9 million. And yeah, this brings us to one of the challenges the city faces, that is the significant traffic burden originating from neighboring areas, with an average of 300,000 cars crossing Riga's border daily, where the congestion is most visible during morning and evening peak hours, obviously. And from my personal experience as everyday public transport user, I can confirm that this traffic is especially noticeable when schools are in season, where a lot of people, as they work in Riga, bring their children to schools or kindergartens here too. And why is this important in the context of public transport? Because when we talk about public transport in Riga, we are not only referring to the administrative territory of the city, but also to neighboring municipalities, as the service extends beyond the city border. Specifically, in the context of today's discussion, the 3 ongoing projects deserve our attention, where the first one is implementation of low emission zone in the city, which also involves modeling residents' mobility patterns, including changes in modal split, and proposing traffic reorganization solutions. Then the second one is development of scenarios for public transport network reform based on travel patterns and travel time analysis. And last one, but not least, the Rail Baltica project, which I assume some of you have heard about, where in Riga, new mobility hubs are going to be constructed at multiple railway stations across the city, which I assume are expected to work in a synergy with public transport. And this leads us to some of the challenges Riga faces regarding public transport. First, it is important to highlight that although residential and workplace distribution has changed over the years, the public transport network has not undergone reform for more than 10 years. Then the second, regarding mobility patterns, graph here that you can see on the slide, shows a significant decline in public transport usage post-pandemic, a trend I believe was observed in other European cities as well. And although in 2023 we saw the highest passenger numbers since 2020, ridership still has not returned to 2019 levels. Third, it is also worth mentioning that mobility costs currently amount approximately 1 billion euro annually, where even minor improvements to the network could lead to cost reductions. And lastly, and perhaps the most critical point within the context of Emeralds project is that while vast amounts of data are generated daily, especially after the Riga traffic company introduced real-time data earlier this year, only a fraction of this data, and specifically e-ticket validations and schedules, is collected, stored, and used for general statistics, meaning that the city is missing the insights from more in-depth analytics. And lastly, before we move to the connection with the project, I want to highlight Riga's medium and long-term development goals. These include reducing CO2 emissions, increasing public transport ridership to 47% until 2030. I would say ambitious, but not impossible if improvements are made. And the last one, prioritizing public transport in the mobility hierarchy. However, this priority is not always reflected in practice, as the planning is still mainly around infrastructure for private cars. And this brings us to the significance of Emeralds project. Juris is going to mention also in his presentation that one of the key focuses is the trip chaining algorithm and drop-off destination predictions, which will result in a comprehensive origin-destination table, where this data, when combined with insights on a population distribution, workplaces, schools, transport hubs, and other points of interest, can reveal passenger travel patterns and highlight gaps in the public transport network. For instance, in Riga, it has already been observed that many peripheral neighborhoods lack direct connections, often making passengers to take trips through the city center, increasing not only travel time but also distance. Additionally, the OD table can contribute to operational improvements beyond the route planning, where like insights into passenger flows and demand at specific times of the day or days of the week can inform more dynamic service scheduling. Another issue that Riga faces is lack of public transport only lanes, leading to vehicles being stuck in the same traffic as private cars, where travel time and delay analysis could provide valuable insights to help the city make more informed decisions about creating these lanes. And here in the presentation, I have also included the results from annual municipal survey that presents residents' opinion, and when asked about what improvements would encourage them to change their mobility habits or like switching from cars to public transport, 18% of respondents mentioned speed, and 12% mentioned the reliability to schedule. Of course, congestion is not always the only factor that affects these metrics. We need to remember that in Latvia we have all 4 seasons, and weather also plays a role. However, congestion is and remains a critical issue where travel time and delay analysis could help to identify where delays occur, their extent, and their frequency. And finally, I would like to highlight cost calculations, whereby combining passenger data from different segments with delay information, we can then calculate not only operational costs, but also broader societal costs of inefficiencies in public transport network. This analysis could include like lost productivity, increased emissions, etc. And additionally, with access to passenger segmentation such as students, pensioners with discounts, and other passenger categories, this analysis could be further refined to reflect the varying impacts of delays on different user groups. Yeah, and like this, such granular insights would support more effective and sustainable decision making regarding public transport network interventions. And Regarding next steps, Yuris will outline our technical plans. So here I would like to just add that our aim is to maintain close collaboration with the Riga traffic company and municipality. We already held one in-person workshop in May this year, and we also try to regularly update them on our progress, but the plan is to continue this way as their input is important in ensuring that solutions developed with the Emerald project aligned with their needs. Thank you.
Thank you, Christine. Very, very quick and very concise, but also explanatory. So, thank you very much for your intervention. And just a few points, if I may. I see that there are some raised hands in the chat. Please, if you have some questions, please put in the Q&A box on the footer of your screen in the Zoom proper box that is made for that. And the speakers will reply at the end of the webinar, nearly at the end of the webinar, during the Q&A session. Okay, so please put there. I put some reference also in the chat for you to have the correct links to the website of the projects and all our channel and social media channels. Please, so now I pass the floor to Yuris, and if you can share your screen, you can start your presentation. And the floor is yours. Thank you very much.
Hi, everyone. I'm Yuris Kondotenko from Grupa 93. As Kristina mentioned, our background is urban planning, and mine in particular is urban economics. So I'm the money guy. And I'm really and this whole project started out with trying to put a price tag on every stop, basically, right? Because we know intuitively that there is a lot of waste in the transport network, and this waste is transferred both in wasted time as well as wasted resources, wasted money, unnecessary emissions, etc., right? So this is actually and we haven't seen this before anywhere. If you have, we would really love to have your feedback on that. So that's the starting point to really have not just like, okay, we spend, I don't know, 100 million euros per public transport subsidy, say, but to have a very specific understanding where this money ends up, not just financially but economically. So to understand what is the society cost of travel. And we are starting out with the public transport, and of course the next steps after this project, sorry, I'm jumping ahead, is to add multi-modality, micromobility, private cars, etc. Right. So thanks a lot, Kostas, Vina, and Kristin for the great introduction. And I'm going to be speaking mostly about the technical stuff. How do we do the job? And I'm not the technical partner. We have technical partners really doing all the coding. So this is like my user case owner interpretation of the software developers' work and my, let's say, high level view of integration and how we are really using it. Okay, so right, the objective, as has been told before, is to have a next step, considering let's say the discrepancy between the wealth and quality of data and the scale of data. It's really extreme scale, because it's like one day only it's at least several hundred thousands of check-ins, validations, and millions of data points for public transport trajectories just one day. And just imagine how much is it over a year and over years, right? So right now the analytics is actually non-existent, and extreme scale of the data is one of the explanations why why this happens. And this the offering of the Emerald project, the extreme data analytics, does exactly that. Because right now this data is like it's within the traffic company. There's a lot of, like, I don't know, like terabytes of data being produced. They of course are kept for some time. Then there are no enough server capacity, so the data just gets thrown away with all the possible valuable insights, right? So here enter Grupa 93 with their vision of what we need as a city, as urban planners. And yeah, so we're starting out with quite basic analytics, quite basic but granular analytics, so to speak, right? So the prototype in 1 year from now, in another webinar, sometime next autumn, we will hopefully be like presenting the operating prototype. I mean, we have the prototype already. It's working. It's there on the cloud. We are now in the middle, but there are some things we are polishing up and developing further. Right. So a way to look at our use case is to look at objectives and go through the objectives. So the starting point, actually, this was the starting point of this project, because we had some our in-house algorithms done, and we are now developing them further with the help of technical partners, is to improve the trip chaining algorithm. Why is it a big deal? Well, the big deal is that in Riga we have only check-in data, right? So every time you let's say you have a ticket, we call it e-ticket. You are supposed to check in in a bus or tram or trolley, and but you don't have to check. You are not required to check out, right? So the system is not there. So we can quite easily by fusing the data, and it's number 3 in this list, by fusing the data of different sensors and different systems, understand where a specific validation took place, but we have no idea how. So where the passenger checked out, right? And I mean, because there was no checkout, just exited. So that's why we have this trip chaining algorithm that has been tested internationally and proven as a quite reliable source of origin destination data in the landscape of scarce data availability as we have here. So we had limited functionality in the beginning, very simple algorithm, basically assuming that I mean we are going into technical details, but the logic of the trip chaining algorithm is that the there is an estimation or assumption that the most of passengers will embark on the next trip not far from the point of exit of the last trip. I mean, and as a commuters, it's really the case. We go back and forth, or we have connected trips with in some transfer points. And yes, so that's again this is the assumptions behind this trip chaining algorithm that's been tested also before in other cities and proven to be quite accurate. So the idea is that we have as much as possible entries or check-ins and checkouts estimated based on the trip chaining algorithm, and then where we do not have trip chaining, so like reliable information, we have ML machine learning prediction algorithm based on the patterns in the data that fills in the blanks, so to speak. So we aim to have, let's say, 100% of all trips, of all rides having determined, estimated the place and time and route and yeah, but basic and line of check-in and checkout. So all right, so this is number 2, and this, I guess, is the kind of main result. In order to do this, we have to fuse a lot of data. You will see in the later slides what are the data sources that we have. And the next one, because we work a lot with geospatial data of specific, let's say, vehicles. We, as an objective, have public transport and street network segment analytics. So basically have an understanding what are riding and delay times in between the stops. It's the first step, and the second step to split the segments into street network segments for further use and comparison with other modes of transport. Right, and when we have kind of when we have the delay, and we measure the delay compared to the free flow, right? So we basically compare the actual time or actual duration or speed in a specific segment versus least possible time and speed, highest speed and least time as characterized by less busy periods. And then by quantifying this difference, we're able to have, let's say, vehicle hours wasted and person hours wasted. And the way to have this person hours wasted is considering we have estimation of embarking and disembarking for each single trip. Then we have algorithm that sort of lumps these numbers together and estimates the number of passengers per specific segment, right? So we have basically like a flow diagram, and I'll show it later with number of people, and then the delay, and with that we're able to really calculate the time cost. And going further, and probably a bit later, I'll discuss how we can be developed even further, right? So that's and of course having nice algorithms is great as for us as data geeks, but decision makers really need a intuitive and dashboard, let's say, where they can see what 20% of data explains 80% of the results. And for that we cooperate with Carto, which is a great GIS platform for data visualization and geospatial data analytics, which is very important for our use case. And yeah, so one of the objectives is really not just to have the data, because we know we have the data already, but to have the information from this data, and then to really have a good visualization case, answering questions decision makers might have. And the crowd density forecasting is really being able to tell to forecast in future what would be the most busy times, lines, segments, stops, etc. So that both city and public transport operator can prepare and plan their both transport infrastructure and the fleet accordingly. All right, so now I'm gonna very briefly characterize the pipeline. So this is how we structure the work technically. And as you see, we have several data sets that surprise do not really talk to each other. So we need to have the interpretation and joining, etc. And it's not that straightforward, unfortunately, right? And those who work with urban data and urban public transport data know that this is the case almost everywhere. Is that the data is supposed to be joinable, but it's not, because the sensors and data, let's say, ingestion is developed by different vendors, and they do not really speak to each other. And we do the interpretation work here with this data fusion algorithm. And once it's done, basically, so by fusing this data, the first kind of interim result is that we have because we have two separate data sets for ticketing data and then for vehicle movement, and these are not connected. We do the connection, and then the first step we basically have passenger or ticket validation landed in a specific route, in a specific line, and also connected to the schedule, which is also is not directly connected with the trajectory or positioning data, right? So there's quite a lot of technical work in this first step. But once we're done, we basically have the entry, let's say, geolocated, and the next step is the trip chaining algorithm. Which is described here, and let's say if we estimate the exits through some heuristics like I've described, and where the heuristics does not work, we use ML to estimate the rest and to forecast, to predict the drop off and destination. Right. So now suppose we have most or all of the passengers, let's say, determined or estimated where they entered and exited the network, and based on that, considering we also for each ride we also have let's say line information and trajectory, etc. We are able to compute OD table, and OD table, origin destination table, we compute on different levels. It's in between the stops. It's in between, which is quite interesting for public transport operator. Then we do the analytics according to public transport zones, and we do also analytics for city neighborhoods. That is not so interesting for public transport operator, but is very interesting for the city. And at this point, we're also able to compare the flows in between different neighborhoods to work census and to work statistics, workplace and residence place statistics, because we have quite good data based on company tax data, where not specific person. I mean, of course, the revenue service has this data, but this data is aggregated. Basically, we have quite good data on how many people work in one neighborhood and live in the different. So comparing this OD information to the data we are, and also comparing this data to population density, we'll be able. I mean, we haven't done this analysis because we're now in the technical stage of work. But the promise is that with this information, we'll be able also to tell what neighborhoods are underserved by public transport, where we have potential for public transport, what destinations, let's say, what combinations of workplace and residence neighborhood are underserved by public transport as well. Right. So yeah. So that's the OD part. I think I have characterized most of it, and basically here you see the intermediate results of the drop-off prediction. Trip sharing and drop-off prediction algorithm. So basically, we have, let's say, data points, how many people entered here, exited there, etc. Right. So and that's visualization of it's not in Carto, but Carto will have similar functionality, I hope. So let's say all trips originating from the most populous neighborhood, or one of the most populous neighborhoods of Riga, Plavnieki, where do trips end, right? So and this data then will be able to cross-check both with the population density as well as specific work residence and workplace combinations. All right, so I guess I'll yeah need to wrap up pretty soon. So the next one, the user story that deals with that deals with the delay and as a starting point, basically. So suppose you have this data, then for each segment we can basically compute how many people are in a specific vehicle in a specific point of time. Then we can further aggregate this data for the network for all lines in a specific segment. And by analyzing geospatial positioning data of vehicles, we're able to determine the delays. And here is the visualization, how we have it. So basically, we have the let's say the delay or time saved, and we have visualization of the network, and from vehicle hours we then can compute the person hours. And I mean, we're not doing this in this project yet, but we know that the public transport company, they do have also some information on ticket segmentation. So with of course this data is anonymized, but in theory, because we don't know how in practice it will work, but in theory you can also not just have let's say across the board uniform cost of personal hour, which is like say approximately 10 euro like per person hour, but have it also a bit segmented because like the students will have a bit different time cost than employed people. They will have a bit different time cost than senior citizens, and based on the segmentation, we will also would be able to estimate cost of time lost in specific parts of the network in specific time. All right, and I have, I guess, already told about how we are lumping the passengers together, and we have the historical data for this, and based on that, and based on fusing with the data on the time of day and day of week and weather, etc., we are then able to forecast how many people will be in a specific part of network in specific conditions, so to speak. So that's what we are going to do, and of course this is very valuable theoretically for fleet planning and management. So this is how the visualization of this data works per line and per network. So basically, let's say, okay, this data, for example, on the right-hand side is quite interesting for fleet planners. The data on the left-hand side is more interesting for the city, where we see the, let's say, the trunk routes, not just in terms of number of vehicles, but a number of people, and the euros spent and euros wasted, right? So that's the natural then point for prioritizing several segments and having public transport priority in different way, and rerouting private private traffic away from the zones that are from the, let's say, public transport trunk routes. Right. So I think I have characterized the data sets. We are working with in this project, we're working mostly with the data sets provided by the public transport company. The next step could be also integrating with other data sets on private car traffic, on population density, etc., etc. You know, there's a lot of data being generated. So we are really excited about the making this project even more extreme, emeralds squared, so to speak, right? All right, and also an interesting point of this project is that the emeralds are integrated in a cloud. So we have MLOps platform by Atos, where the different emeralds, let's say, are integrated and talk to each other and ingest the data in real time. So basically, the manual work in uploading the data and let's say connecting the different tool sets is minimized, and then the results are transferred to the Carto network, where they are a bit further processed and visualized. Right. So at the moment we're like midway through the project, and we have quite good feeling of where it's going. So let's say we have the time in the project now we've mostly spent on the back end, meaning we've worked mainly on the algorithm, and we haven't worked yet with the data analytics per se. That's actually for the next year. So now we have, like, let's say, quite good basic functionality, and we can start really producing the results and having this feedback loop of data analytics and seeing what we really get out of this, and then based on that improving the emeralds or algorithms for data analytics in this project. And we also have quite good cooperation with the city and public transport company, and they're like really okay, when are you gonna have the result? We're really eager to, and like whoa, wait, it's not TRL 8, it's TRL 5, right? So that said, we have a quite good potential, hopefully, for the work after this project ends. So we hope in the end to have a working prototype of this cloud-based data analytics platform, and to be then further developed to suit the needs of public transport company of the city, as well as potentially other cities worldwide. So that's it from me. I guess I've a bit overspent time, but hopefully it's been interesting.
Great. Thank you very much for, this is a very interesting contribution to our webinar from your perspective. And I say that, I must say that we are perfectly in time for our last session dedicated to the questions. So once again, I'm asking to the audience to put their questions, if they have, in the Q&A box in the footer. So all the speakers are here for you to reply to your questions. But in the meantime, I would like to have, to pose a question to the speakers, let's say to all the panelists. I don't know who wants to reply to this question that arrived before the webinar, and it was regarding the regarding this. So the question is, how do you know the results estimation algorithms are accurate? So I don't know who wants to reply to these questions, and maybe you can pass the floor one each other in case you have something to add. Please, thank you.
Yeah, I mean, a very good question. First of all, thanks for the question. I think that's the question that we keep asking ourselves. Let's say because a lot of work we do based on estimation, right? So it's like, how do we know the results are accurate? The good news is that we have in the city other sensors, for example, this automatic passenger counting system that allows us to cross-check the results. Of course, it does not. I mean, the passenger counting system does not give us an information where specific ticket was validated and where a specific ticket holder exited. But by lumping, let's say, if we've done our estimation right, then the passenger counts should be quite close by, right? So that's one thing. And we haven't done this. I mean, we have done some of the assessment. A part of the problem is that also that system is not really integrated. It's like, historically, Riga public transport has been like 3 different companies: one responsible for buses, one responsible for trams, one responsible for trolley buses. You know, the cable cars, it's still not like fully integrated. So you have even different systems based on different sensors, based on different vendors. So we've been. So that's one of the part of the story that it's quite a big overhead for the public transport company to provide the data and to because it's not their kind of core business, so to speak. So it's an iterative process. We need to get something to show the utility of this analysis, so they invest more time into getting more data for us to improve our work. You know, it's like because everyone is very very busy. But again, to answer this question, we have some other data, at least potentially to cross-check. To take full advantage of this opportunity, we first need to showcase the results to the stakeholders, to make them more interested to invest their time in helping us and helping themselves. Actually, that's one question. So yeah, we have some procedures and assessment, let's say, routines in place and in our plans. The next question is, starting from zero, where you have basically no idea of where the people are in the network, going to 100% accuracy is a big stretch, right? So we are hoping, let's say, we have put as our benchmark, let's say, 20% accuracy. We want to be plus minus 20% correct in estimating the number of people, but that's quite ambitious. We understand. So just knowing the scale of things, you know, just whether it's, let's say, it's 100 or 10 people is already valuable. So it's one thing, and also the geographical kind of aggregation. Having been very accurate on a stop level is probably quite tricky. Being more accurate on a transport zone or neighborhood level, which is then valuable for the city, is perhaps more practical. But we are doing the assessment next year, and I will be able to answer your question fully 1 year from now, or 3/4 of the year from now. Yeah.
Thanks, Juris. Yes, that's an interesting question that we keep asking ourselves. I would say that you use the word utility. I would say that, yes, indeed, utility is a very good word. But I would also like to add here the word of efficiency of the solutions in terms of replicability. How do we know that, let's say that we are operators from a different country. Can I use it as a solution? That's a question that we're trying to create solutions that are closer to data sets applied to different cities, for example. So Winnie, Christine, and you, Juris, describe the use cases and the technical part and the business part. So I would say that it would be quite interesting to discuss the replicability of the solutions to other cities.
Indeed.
I don't know if
Great. I don't know if anyone, yeah, exactly. I don't know if anyone else wants to add some points on this. We are almost at 11, so we have 1 minute to close. So if you want to reply to something, or Christine, Winnie, or otherwise we can close the session.
Yeah.
I would say that, I mean, I want to thank all the participants and first of all the speakers that gave their perspective today and made us aware of the advancement in the use case number 3 of the Emeralds project. So as I said at the beginning, please follow us on our social media channels, on our website. I put everything in the chat, so you can find all the details of the project. Thank you again, and have a good one, everyone. Thank you.
Thank you, everyone. Thank you.
Thank you.